And thank you for the warm invitation here, and it's great to be here. I yeah, my team was mentioned, and I see a lot of familiar faces here in the crowd who have visited us in our innovations lab, which is in Milan. That's our biggest hub, and everything you see today is indeed on show in that lab live. And we do invite our customers, both remotely and physically, to see the solutions put together in an end-to-end format, and also we can adjust it as per our customers' requirements. Straight into it though, folks, and there's two main areas that we want to delve into. The first is, and I won't go too much into the requirements, I think the main two aspects are we will be building the most sustainable and profitable networks in a manner that is outlined in three main steps. The first step, I think that many of us have been through, is service convergence, but we say service convergence plus, because with that, not only do we converge current services and combine them onto a single network infrastructure and therefore becoming significantly more optimized, but we also want to ensure that those services can be significantly improved, enhanced, and flexible to new requirements that the market is looking for. Second, once we've got all those services onto a single infrastructure, we can absorb the optical infrastructure or the transponder layer into that now converged IP/MPLS network. Again, kind of getting another multiplier effect in terms of the efficiencies of networks for the future. Once that's in place, then it's actually much more malleable to automation. And you'll see that with a collapsed infrastructure and common set of APIs, standards-based, of course, then the ability to automate those networks becomes far smoother, and indeed supports the additional service requirements that are put on these networks over time. So starting off with number one there in the middle, the service convergence. We've all spoke a lot, and I know it's been discussed for probably 10 years in forums similar to this, is segment routing. I won't be spending too much time on it because I know you'll be familiar with the technology, but do please ask us if you would want any sort of deep dive or introduction to some of the enhancements in segment routing. But we certainly believe that segment routing is the service convergence enabler. And we'll just go through a couple of service examples and SLAs that can be built up over the same infrastructure that's supported through segment routing. If we imagine that this kind of light green node here is the access node, and segment routing is supported right the way through the vast majority of our portfolio right to the access, and I'm pleased to see that across the industry segment routing is widely supported. So if we imagine we have a cell site router here, it may be a cell site that's enabled some further radio distribution. It could be, for example, on the top of a new build business park, and it's actually a converged cell site that's bringing in the nearest enterprise port as well. You know, if you've got a multi-service capable network, why not bring the enterprise directly into that cell site router? We're seeing that increasingly. And of course, the most fashionable SLA to talk about with 5G is low latency. What we're able to do, of course, we're able to automatically steer traffic across the very lowest latency path. Many routing protocols have done that as standard almost, but latency varies in networks, particularly big ones based on various networking events, and we're able to monitor that latency. If there's a change in it, we can auto steer that traffic. It's basically colored and is auto steered over the very lowest latency path. You can also put a bound on that latency to maintain that particular application's SLA, whether that be augmented reality, whatever low latency application we're gonna see in the future that requires such an SLA. The next one, still the vast majority of video, of course, is not of traffic is not latency sensitive, and mainly because that's video. So if your protocols are by kind of default taking traffic over the lowest latency path, even video may go up that path, and it's kind of building and exacerbating the requirement on that particular link. Do you want to do that? Not if you've invested your good money into other paths in that network. You want to utilize as much of the network as possible, so why not take it over a less utilized path and therefore getting more bang for your buck and optimizing again that overall network utilization. We've worked with a lot of providers who have not necessarily been mobile players, but they have they're very fiber rich, and an additional upsell service and a very popular one, particularly with 5G rollouts, is to offer a 5G mobile backhaul service. Fiber is often the key to an efficient 5G backhaul. If you have the fiber and you may be an enterprise focused business, but you can offer that capability to a mobile player who might not own that same fiber and have that same footprint. So why not monetize it? And again, segment routing is highly adept at providing that type of service. Quite a simple one to bring up and offer to your customers. A particularly interesting one for enterprise customers is that of disjoint path. Typical IP/MPLS networks have been unable to achieve this, at least operationally viably. It's extremely complex to offer that service end-to-end across a network, but now with segment routing, we can guarantee that disjoint path, instantiate it actually very simply, and offer that to the enterprise customer that may have been buying one service from one operator and another from another, thinking they were entirely redundant, but one day finding that that particular fiber was being shared across both operators, and both services came down. Obviously, they'd be paying double for that, one from each operator. So the monetization factor of this service is particularly high because it's actually better than such a doubly paid for service. So highly monetizable for the CSP. And finally, I think as an industry, MACsec has not been widely adopted across all platforms that vendors have to offer. It's certainly the same at Cisco. It's a costly addition to a platform, and therefore folks have only purchased it when it's really been required. And for that reason, you may not have full MACsec support across your network, but you may have one path that's MACsec capable. It may not be the lowest latency path, it may not be the most efficient, but it may be the most secure. And a particular enterprise, for their perhaps sensitive financial applications, may be willing to pay extra knowing that it's MACsec enabled. And we can bring up that kind of slice, if you will, in its own with something called segment routing flex algo. You basically bring up a subtopology that is MACsec capable. And again, highly monetizable. Talking about sustainability, we're actually studying in that Milan lab the ability to gauge what power consumption, which power grid each of those routers are on, whether that particular power source is sustainably enabled, for example, through hydroelectricity. So you can actually even offer a green slice to your customer. It's well, not today. We're actually working on it in the lab, but all of those that you can see on the slide we can offer today, and we're looking at that kind of green VPN, green slice concept in our innovations lab down in Milan. So we're just trying to kind of convey the fact that you can really offer all services over a converged network, even circuit style services very shortly, which is extremely powerful in itself, because we still see a lot of networks that are built, different access aggregation networks per service type, because they've had different requirements and the platforms and protocols have supported different things. Now you can basically do it all in one. I think we've got about over 200 deployments in segment routing worldwide, and there's very many more planned. Crucially as well, these service instances are now SD-WAN overlay enabled, in the sense that we can kind of glue an SD-WAN overlay to these much more stringent underlay SLAs. And we think that's crucial because it gives the service provider ultimate SLA control And instead of those SD-WAN services kind of traversing the relatively uncontrollable internet, if it's just an internet service, we can tie that and glue that that SD-WAN SLA into that underlay, which is very powerful, we believe, for the CSP in order to utilize also their last mile footprint highly effectively. And that actually takes us into a concept that we're seeing growing in the market. Gartner defines network on demand as basically services that enterprise want to consume in a much more flexible manner, and ideally over a portal like we saw very well demonstrated earlier. The ability to adjust the access port bandwidth, change the WAN service types, all under software control, ideally under that portal, or at least through standardized APIs. And the construct and the tool for the service provider is what we see as network as a service. Obviously, this should be cross-domain. It should cover some of the capabilities that we've seen earlier. It should be able to observe that those SLAs that we saw earlier are being adhered to, and can be proven to be kept up over time. And crucially, I think this links into that overlay-underlay tie-in, whereby the CSP holds all of the keys to be able to entirely offer that network as a service construct end-to-end across that network. And we're going to see, I think, a lot of different use cases for network as a service. We're seeing many of these already today. It could be site-to-site connectivity. It could be site-to-edge across and over your on-net footprint, and also site to service exchange. And that service exchange may well be on your net, but it may well be off net. It may be a partner. It may be a part of an ecosystem service offering that you're taking to market to enable enhanced connectivity into a third-party ecosystem service that you're developing as an operator, and it may well be to the public cloud. And we believe that this network construct and that ability to tie those overlay services, in this instance, as you move into the overlay and across your underlay that you've managed the SLA for, can be a really great cocktail for the service provider to enable these sorts of hybrid ecosystem networks and services that we're starting to see across the globe. So I won't talk too much about product, but I think the most important aspect is that our iOS XR operating system that has been developed really from the last more than 10 years around segment routing is now available end-to-end. We've done a lot of work to optimize it. It was a little bit memory heavy. It was taking quite a long time to boot up. We've shrunk that down by about half in terms of both boot up speed and memory footprint, so we can get it onto cell site routers that are 1 RU and 24 centimeters deep. And just a quick look at the portfolio. That's basically end-to-end in terms of the cell site routing capability of the NCS 540, all the way to the 8000 series that is being used in core and peering networks today due to predominantly its immense 400 gig scale and its efficiency from a power consumption perspective, right the way through all of the different options you have across pre-aggregation, aggregation, and edge. Crucially, that gives you a common set of APIs, and it gives you the same embedded security capabilities, and also it's the same flexible consumption model. I don't think there's many of us that need 36 by 400 gig line cards today, especially if you're looking at line card redundancy that most of us want in a modular chassis. So you can start paying for significantly less, and as you grow, you can bring up those ports very quickly and operationally effective without paying for them up front. So that was around service convergence. The next step is really around layer convergence. And I think it's very powerful to consider quite a simple explanation of why perhaps optical networks have existed standalone until now. In most networks, they still exist today. And I think largely it's because we didn't have service convergence. we had separate access aggregation networks, at least, maybe even cores, built around different service requirements and service types, wireline, wireless, business, wholesale even, maybe, so it's maybe 4 to 1. And that particular optical domain was aggregating multiple 3 or 4 different switches or routers to take over a bigger pipe, and that gave it that gives it a very strong utilization versus if we put pluggable transponders in all of these disparate access aggregation nodes or aggregation nodes northbound. You wouldn't gain high utilization, and it kind of made sense to aggregate in that optical node and pump all of that traffic northbound. Now that you've at the bottom there, we're bringing all of the services over a common infrastructure. Northbound, it's still 1 to 1, right? It's not 3 to 1 anymore. It's all 1 to 1. All your traffic's going to go into that router, and it's all probably IP based, or at least it's 95% IP based. And then northbound, you put a big pipe out there over 400 gig, even from your pre-aggregation. And I know we'll be talking a lot about in the conference. I see in the agenda about that type of those 400 gig pluggables, and we'll take a little bit of a look at them in a little while. And also why now, from kind of a technology trend and cost point perspective and evolution, there's something really interesting and really huge that's happening in terms of network economics, and that's that the actual platform, the network devices per gig, are going significantly down in terms of their cost curve, power curve, generally efficiency. It's actually beating Moore's law in a lot of cases over the last few years, and that's been driven by some really, I think, great silicon processors across the industry, and it's really been incredible to see that efficiency per gig reduce drastically on the network side. But on the optics side, we're not seeing such a big and steep cost curve decline, and for that reason, the optics as a proportion, the optic component as a proportion of the cost of a link is growing significantly, and it's outpacing that of the network device itself. Which means if you look at 100 gig or a 400 gig bill of materials for a link, you'll start to see that at 100 gig it was maybe 50-50, at 400 gig it might be 70-30, or even more weighted on the optics side. So basically you want to get rid of as many optics components and optical components as you can if you want to be leading the efficiency and riding the efficiency waves that we're seeing in these two technology spaces. In the middle there, you've got a lot of optical components, and they're not, if you're running separate layers, then that's not going to slow down. You're going to have obviously your optics between your router and your transponder shelf. That's on the router side and the transponder side, and then you've got a dual gem optic going northbound, for example. And I think technology fragmentation is something that we've seen not improve greatly in the optical industry. We still see a lot of non-standardized components, some very expensive materials being used. Silicon photonics is starting to take off, and we need to use that as a benefit to actually gain standardization and to drive down the costs, instead of everybody developing many different components that aren't going to drive down the overall cost. But I think all of this is changing, and I think this is what is driving a lot of the convergence we're going to talk about. And because of the massive increase in the importance of optics and optical, Cisco have been doing quite a few investments of late. The most I would say that the biggest ones in terms of how it's going to affect the architectures we'll discuss today. The Luxtera is very interesting because that brings in-house some leading manufacturing processes in terms of the automation of the silicon photonics processes, which means we can, those gray optics that are always going to exist, we don't always have to go over long haul, can be extremely optimized, and we can bring those sorts of manufacturing processes in-house and extend those economies to our customers. But I think crucially Acacia, which are really developing and continue to develop incredibly innovative high-speed coherent optics. And this is where we start to see the delivery of in-house 400 gig coherent optics over the last year or so into the portfolio. And that really, I think, changes the game in terms of what we can offer, at least end to end, in terms of integration into our supply chain. Where do they fit in terms of the high level architecture? You know, if you've got a grey optic, you're using a fiber pair, you want to go from either within the POP or you want to go you know, up to 10, 20 kilometers, then why not use you know, just a standard grey optic? And that's where the Luxtera silicon photonics come in, and also obviously interconnecting that router with a optical transponder shelf, which gives you the kind of classic IP plus DWDM construct that we see in most networks today. If you think that we've been expensive on pluggable optics over the years, you might be right. Probably you are in quite a few areas. Not anymore. And I would say challenge us in terms of us being able to hit a healthy price point and with some really great quality that I think we can prove out. But again, from an architectural perspective, the most interesting point is the fact that you can kind of collapse that transponder into this pluggable optic and go right into and plug that right into your router directly. And that gives you that IP over DWDM, as the terminology has always been, that layer convergence that is going to create really efficient, really sustainable networks as a further kind of icing on the cake of converging those services. Why not bring the layer in and the DWDM transponder function into the router? And specifically, this is the optic that we think is changing the industry. It's standards based. We're basically bringing in all of those similar capabilities that we've seen driving down the platform cost into the coherent land in terms of silicon photonics. It gives us ultra low power and really great economies of scale, because the industry is getting around this type of silicon photonics as well, so we can drive down together the price point and the efficiency of the manufacturing process. We can, you know, obviously focus around multi-vendor interop and around standardization, which is, I think, great for the industry and gets away from that fragmentation that we've seen. And crucially, where in the past, if you've tried IP over DWDM at 100 gig, for example, or 200 gig, you had to buy a different type of line card often that supported, I don't know, a CFP2 form factor, or it needed even a digital signal processor on the line card itself. Not anymore. You would buy, for example, a 36 by 400 gig line card, and you plug in those ZR plus optics into those ports, and it becomes kind of a DIY combo card, if you will, and there's no density trade-offs. You've got to watch out on some line cards. We have heat dissipation constraints and cooling constraints, and some power constraints because they're a little bit higher power than the 400 gig grey. So you got to look at which line cards, how many they support. But typically we don't have a problem because not all the ports are needed to be to go over the long haul network anyway. But it's just something to bear in mind. We talked, I briefly mentioned 100 gig and 200 gig. You needed different line cards. The whole industry, I don't think, had really driven the CFP2 form factor. It was significantly bigger than the QSFP28, and that was giving us decent power savings. But even at 200 gig, 33% power savings approximately wasn't enough to kind of drive this almost revolution in terms of how networks are built and drive that convergence, which can sometimes be organizationally challenging and operationally, of course, challenging. But now with 400 gig, we're looking at about 68% power savings. And that is the sort of number that makes people stand up and take notice and do revolutionary things in their network. And I think this is probably the most important factor that's going to drive wide-scale mainstream adoption of this type of integration. this is high level, how you kind of achieve these power savings. And we've imagined it's the same router here. So like a 400 gig capable router in our portfolio, that's the size of these boxes is the approximate proportion of the watt per gig that is driving the power consumption of these networks. So we have the same it's in a kind of business as usual separate physical layer. We have the same router. Watt per gig, of course, it's the same router port. On obviously in this separate physical layer, you'll need two grey optics. We imagine here at 400 gig, you would need one on the router and one on the external transponder to connect them. And that, interestingly, two of those is about the same power consumption as one ZR plus optic. So you're already the same power consumption without the external transponder. Now, we can all debate how much different vendors' external transponders take, and some might be more efficient than others. But the key message here is that you get almost for free from a power consumption perspective the transponder function. You negate all of that external transponder power consumption, which makes for in this case that 68% saving. If you'd go through such a transformation, including service convergence, if you go through such a transformation, including an upgrade of that router to a more efficient 400 gig, you might even get more. We've even seen 90% in some TCO modeling exercises we've done. Sometimes less than 68, sometimes it's 45, depending on the current technology and the traffic patterns. We'd have to look at everybody's network individually. This is very simplified, but it's really, really powerful. So, you know, this is a journey, and I don't want to paint this out as that this simplification is and this collapsing of layers is a simple one. It's a long journey. But just to paint a picture in terms of what we see sometimes today in a lot of networks, we actually have 3 layers. We've only really talked about 2 today, IP and optical. We often have that packet layer, an OTN management plane to deliver OTN services, and a DWDM plane and the different management associated with those 3 different layers. What we propose over time is moving to an entirely flat network, at which point you gain great operational efficiencies, simplification. We talked about automation. Everything becomes much more streamlined, and we can deliver the capabilities to go to a full flat, let's say, highly malleable network infrastructure. And that really becomes a discussion around automation and giving the powers that you've had before with separate layers, expanding that and migrating that to a now converged, let's say, SDN automation capability. So this is kind of step number 3, right? Once you've collapsed those layers, once you've collapsed those services, it becomes far more malleable to automate. You obviously you'll know very well in the region, NSO, of course. The Cisco Crosswork solution embeds NSO into the network controller. We are bringing within that some investments that we've made in terms of hierarchical controllers for management of those and migration of multi-vendor, multi-layer networks, really into an end-to-end closed loop multi-vendor automation platform. We realize that that it's so crucial that we maintain and we continue to enhance and improve multi-vendor capabilities, particularly in this space, because especially from an optical infrastructure perspective, we have to be entirely open. We spent a lot of time doing, for example, alien wavelength testing over third-party optical components, the ability to help operationalize the automation of those multi-vendor networks is complex, but it's a massive area of focus for us, and we've come a really long way. Obviously, it depends on the present mode of operation in your particular environment, but please, I'll be very happy to discuss in detail with you and my team around how we can automate and take you on this journey as we move through those various layers of convergence. A couple of examples of the time saved through automation. It's normally high level, and we've done quite a lot of modeling exercises on this. It's approximately 70% time saved as you move to an automation-driven network in terms of, for example, mobile service provisioning and migration and zero-touch provisioning. We've done some really huge mobile backhaul zero-touch provisioning projects of hundreds of thousands of cell site routers. Obviously, we only have maybe 10,000, 15,000 in European countries, and I think we've got some really good experience around that. We wrap now zero-touch provisioning in with our secure boot functionality, which means that when we're requesting that software upgrade from the cloud, we ensure that it's not been tampered with. It's still the same that came out of the secure development lifecycle at Cisco, that the hardware's not been tampered with, and then we bring up that image on that router without having to have a very technical operation out at the cell site, for example, and that's across the portfolio. So normally we're looking at about 20 minutes, if that, actually, from a zero-touch provisioning perspective. Which significantly cuts down operational costs for the CSP, of course. So I've got just a few minutes left. I want to leave a bit of time for questions. High level, and this is really high level, right? Present mode of operation on the left. It's basically, you've got multiple access aggregation networks that have perhaps been built per service type. You have still a separate transponder layer from those routers, and typically actually heavily centralized services, which we haven't talked about, but of course they'll be moving deeper into the network as we move forward. On the right there is where we want to move to. So obviously it's a convergence of those services over a single unified segment routing-based pre-aggregation up through a now fully converged network. You'd be surprised, even at pre-aggregation today, 400 gig northbound sounds a lot. But after you've aggregated all these services into the same node and you've looked at the price point and the power efficiency of 400 gig, anything above 100 gig, you're probably better off going with 400 gig. It's hard to believe, but that's what most of the TCO modeling that we've done has given its output towards. And then, away we go. It's 400 gig, basically. Ideally, ZR pluses northbound from pre-ag right the way through aggregation into core, and then perhaps your peering. We've done quite a lot of work early rollouts of ZR plus have been from core to peering points, which is a very simple application, a good kind of foot in the door to this type of operational environment. Otherwise, it's just grey optics with perhaps some of those that look stare silicon photonics taking us to that if it's a local peering point, for example. Power saved in the region of 68%. There's going to be at least 60% less nodes, and really that's also less stuff to go wrong, right? Which I think crucially helps to enhance SLAs. And just, I won't spend too long on this kind of wedding cake here at the bottom, because we've talked about that in terms of the savings, both mainly from an operational perspective, but in terms of the kind of top line benefits, and this relates to monetization of your network. We talked about some of the SLAs we can achieve at the start in terms of guaranteed disjoint paths that can be doubly monetized into your enterprise customers, lowest latency SLAs, MACsec kind of subtopologies being built and sold across that network. If you look at the MTBF of the network on the right to the network on the left, it's a very complex calculation, but the uptime will significantly improve with a converged infrastructure because there's just so much less stuff to go wrong. And that is really powerful, we think, from a monetization perspective, because as you know better than I, the highest uptime networks are the best, and they keep their customers and they grow their customer base. There's one particular one I want to call out, and that's sustainability go-to-market. We talked about trying to build like a green VPN service that you could offer to your enterprise customers that we think would be highly attractive. But if you read some of the reports, I read one done by Boston Consulting Group, and they believe that particularly young consumers will be willing to pay 10% more for a mobile operator that they think is the most sustainable in the country. And I think that's a very powerful figure, and I think that's just going to increase. Sustainability not only helps us help the world, but also it's directly linked to your OPEX, which we can really help to significantly reduce. So with that, folks, I have 4 minutes for questions. Would anybody like to ask one?
Thanks, Ben. Any questions for Ben? No. Okay, well, please join me in thanking Ben for his presentation. Thank you very much.
Thank you.